the remaining concept that you have in sound waves is intensity level. So that means we're taking a look at intensity level. All right, intensity level of sound waves. Okay, we're looking at intensity level of sound waves. Okay, now is the intensity level and intensity the same meaning? The answer is not. All right, intensity has its own definition. Intensity is, we have already discussed, is the power dissipated. All right, as the waves move or traverse a certain medium, the power dissipated by the waves per unit cross-sectional area. You say cross-sectional, that means it's already perpendicular. The area must be perpendicular per unit cross-sectional area of the medium in which the wave travels. That is intensity. All right, that is intensity. But if you're talking about intensity level, that is a different meaning. Intensity level is the measure of the loudness of the sound. The measure of the loudness of the sound is intensity level, and it has its own units. The unit is bell, which is which is symbolized as capital B. So this refers to loudness of the sound, how loud the sound is, and the unit of measurement. The unit of measurement is bell, which is capital B. But bell is a very big unit actually. All right, very big unit. The loudness we are subjected to doesn't amount to the bell. It is more of decibel. That means it is not to say it doesn't amount to a bell. What we are trying to say is bell is too big a unit for loudness. So we use a more practical unit, which is decibel. All right, dB, decibel, just like decimeter. Decimeter. All right, so intensity level is a measure of the loudness. Intensity is the power of the wave that is dissipated per unit cross-sectional area. Now, although they're different, but they are related. Related in the sense that the intensity level is determined by the intensity of the wave. Intensity level is determined by the intensity of the wave. So the relationship is such. Intensity level is symbolized as capital L. Capital L refers to intensity level. Okay, how is the intensity level linked with intensity? It is the intensity. This is the formula that links. So I want you to remember the formula that links. So it is 10 log to the base 10, or you can simply put it as LG. All right, log to the base 10. Ratio of the intensity of the sound. That means every sound has an intensity. Let's say this is sound A. So you want to measure the intensity level of sound A. Everything must be clear. So you need to know the intensity of sound A. So this is the intensity of the sound A, whose intensity level you are measuring. All right, whose intensity level you are measuring. And this intensity of sound A is compared to the threshold intensity. Is compared to the threshold intensity. This is a threshold intensity. So here, let me specify that this is intensity of the sound whose intensity level is being measured. All right, all right. And I naught is the threshold intensity. This value will be given to you. This value will be given to you for the calculation of intensity level. All right. And normally this is equivalent to 10 to the power of minus 10 power. The unit is watt per unit cross-sectional area. So this is considered, the threshold intensity is considered as the minimum intensity of sound waves. Minimum intensity of sound waves that can be heard. That can be heard. All right, in terms of intensity. So in terms of intensity, the sound wave must have a certain minimum value all right, for it to be heard. And that minimum value is known as the threshold intensity, and that is about 10 to the power minus 12. Don't forget at your lower form, you have learned what we call the threshold frequency. Threshold frequency will be the minimum frequency of sound. Threshold frequency is the minimum frequency of sound that can be heard. And that minimum frequency for human being is about 20 hertz. And we also have the upper limit. The upper limit, that means upper threshold limit will be 20,000 hertz. All right, here we are more focusing on intensity. So that's so you substitute and you'll get the value. Now this 10, all right, is because it's in decibel. That means the unit of L will be in decibel. The unit is in decibel, all right? Because the unit is in decibel, that's why the 10 is there. If you want to know why is there a 10 there, because you have brought the unit to decibel. So what if you don't have the 10? Then the unit will be balanced. If you don't have the 10, the unit will be balanced. So just watch out for all this. This is, it's quite direct. It's quite direct. So intensity level is the measurement of the loudness. Okay. All right. So that's all you need to know in terms of intensity level. Now application. Application means how is it related? So let's say this is sound. Let's say this is sound. All right. Sound source. This is the source of sound. Source of sound. All right. Okay. So at a certain distance R, you have an intensity level here. So at this point, the intensity level here is level 1. So if let's say this is R1, right? And let's say at a certain distance R2, the intensity level is level 2. Okay, all right. Now, is the intensity level at this point, and this point, which are designated by the distance, are they the same? Of course, the answer is not the same. Intensity level at 1 will be greater than the intensity level at 2, which needs to be calculated. All right. So the question is why? Why is the intensity level 1 is greater than level 2? This is because intensity level depends on the intensity of the sound. It depends on the intensity. This is a constant. This is a constant for both situations here and here. That is what you have to know. At L1 and L2, I0 is a constant. Because that's a threshold. All right? What will be different for L1 and L2 will be your I. This one you have already learned in the previous lesson because I, okay, is inversely proportional to R squared. Remember R squared, not R. R squared because sound is a spherical wave. Sound is a spherical wave. Remember, because sound is a spherical wave, is a three-dimensional wave. Sound wave is three-dimensional. Three-dimensional is spherical wave. That's why it's R squared. So because of this relationship, all right, that means that means here, I1, I2. Because of the relationship of I, which is inversely proportional to R, therefore the I1 and I2, the I2 is smaller than the I1. I1 is greater than I2. Because of that, the intensity level will not be the same. So, which means if you are asked to find the intensity level of this compared to this, you've got to bring your I1, you got to bring your I1 and I2, and you got to relate with this relationship. This relationship must be factored in. Okay, you got to bring in this. We will show a calculation after that. After that, I'll show you the calculation. Must be factored in its calculation. That is what I'm trying to tell you. Okay, so